Everyone. I wanted to introduce Imran Umar from Booz Allen, one of our strategic partners in the federal space. And this afternoon, he's going to discuss how to build a scalable zero trust architecture for modern cyber. So please welcome Imran.
Thank you, Vic. So, first of all, appreciate Cribl for giving me an opportunity to speak here. My name is Imran Umar. I'm a Senior Vice President at Booz Allen Hamilton, and I lead our Cyber Defense Zero Trust practice across Fed. Today, I'm going to talk about an actual use case where we're implementing a Zero Trust architecture for a Department of Defense client. And I'll talk about some of the challenges we ran into from a defense cyber operations perspective. Raise of hand, how many folks here have heard of Zero Trust and the journey of Zero Trust? Okay, good. For those that haven't, I will do a quick intro on this whole concept of Zero Trust, why it is important. Then I'm going to talk about some of the challenges when you implement Zero Trust, especially from a defense cyber operations perspective, and walk through an actual use case. So why is Zero Trust important? So the main caveats, the main reason people are moving towards Zero Trust is, first and foremost, digital modernization. You have customers across, commercial, the private sector, DoD, intel agencies. They're all moving to a modern architecture, whether it's cloud, they're using things like mobile devices, bring your own device. So the attack surface has changed. When you used to have all these applications in a data center, somewhere on premise in a private data center, you had basically a wall that would protect that data center. But as you're moving out of that data center more into cloud services, your attack surface is changing. So digital modernization is one of the key drivers of why people want to move towards this new paradigm where you're not just defending the front wall, you're defending the inside of your environment. The second thing is the new threat vector. So every day you guys hear about new kinds of attack. The big one that happened several years ago called SolarWinds was an eye-opener. You heard something more recently that happened in Europe with the airline industry where they compromised their registration systems. That was another ransomware attack. So the threats continue to evolve, and especially in the world of AI, you're going to see a lot more attack vectors. In fact, AI is going to become the new attack surface itself. And then finally, there are policies that are mandating the deployment of a Zero Trust architecture. So DoD CIO and NSA put out guidance that by FY 2027, all DoD organizations must be on a validated Zero Trust architecture. So those are the main drivers. So what is the Zero Trust architecture in a nutshell? There are three major principles. The first one is assume breach, meaning that you're already compromised. So if you have an application that's hosted, or if you have workloads or data, well, you have to make an assumption that the bad actors are already inside your environment. So you're now going to design the environment, not just protecting the perimeter, but protecting every aspect of the environment, using things like microsegmentation, reducing blast radius, et cetera. So this whole mindset of I'm already compromised is a fundamental principle of Zero Trust. The second one is never trust, always verify. This is basically anybody that's accessing an application, anybody that's accessing a resource, you have to continuously validate using what's called conditional access. Conditional access could be everything from user device posture, user identity, behavioral analytics, geolocation. You're taking into account all these different factors to determine what resource a user in a device can get access to that they're authorized for. And you're doing this in a dynamic fashion. It is no longer, hey, static, yes or no, give access or deny access. The third major concept of Zero Trust is least privilege access. This is denied by default. So anybody that wants access to an application or a resource, you're going to deny it until they prove that they are authorized to have access to that system. So taking these three high-level fundamental concepts, you start to build out a Zero Trust architecture. The way DoD CIO has outlined Zero Trust is across different pillars. So they have the user pillar, the device pillar, the network pillar, the data, automation, orchestration, visibility, and analytics. And you got to basically merge and integrate all these different pillars into an architecture that achieves an outcome of zero trust. One of the projects that I personally am very passionate about, that I've been supporting over the last few years, is for a Department of Defense called Thunderdome. It's run out of DISA, the Defense Information System Agency, that I've proudly supported as a contractor for several years. And one of the things they ask us to do, the way I like to explain DISA is they're a large service provider for the Department of Defense. So if Army, Navy, any of the MILDEPs, COCOMs, they want access to any kind of a transport, network, enterprise services, well, DISA is the agency that provides that. So they awarded Booz Allen the Thunderdome contract, and they asked us to implement a zero trust architecture across their different classification of networks. The very first thing we had to do was conduct a zero trust maturity assessment. So DISA has a lot of, just like any other organization and agency, like pick your DARPA, Missile Defense Agency, et cetera, they all have existing investment, existing infrastructure, things like identity access management. They have an EDR solution. They have a SIEM. They have a comply to connect. They have a privileged access management solution. So the goal was go in and conduct an assessment to do a complete inventory of the as-is and build them a roadmap of a 2B architecture. DoD CIO published a couple of years ago target and advanced level activities. The goal is to achieve target, which is 91 activities by 27 and advanced by 2030. So the first thing we did was we deployed a solution called Zero Trust Remote Access. So we had, especially during the COVID time, we had a lot of customers, a lot of users that were working remotely. And traditionally, people have used things like VPN technology. We wanted to get away from this concept of VPNs where you're not really implementing conditional access. So the first thing we did was we implemented a secure service edge solution, a SASE or SSE capability, that continuously validates your device posture, user identity, behavioral metrics, et cetera. So we implemented a cloud-hosted SASE solution. So the idea here is if a user is coming in remotely, whether they're on their a mobile device or a thick client, we are now routing their traffic to the SASE as a single policy decision point and a policy enforcement point. We integrated that SASE solution with an identity and access management solution. For us, it doesn't really matter what the ICAM solution is. It could be Ping or Okta or Entra ID. We are very agnostic because we build a very open and a modular architecture. And when a remote user is coming in and accessing these applications, they're typically going to a public cloud where an application is hosted, either SaaS, IaaS, or PaaS, or they're going to a private cloud, or they're going to the internet. So the first thing was secure remote access traffic end-to-end. The second thing we did was, if you look at this graphic left to right, we implemented a Zero Trust Edge solution. The Zero Trust Edge solution is deployed on-premise. It is basically providing the functions of a policy decision point and an enforcement point, but for on-premise users. So if I'm physically sitting at a base like Fort Meade, I want my traffic to be inspected locally. I'm not going to hairpin my traffic to a cloud-hosted SSE solution, because one of the goals of Zero Trust is inspect the traffic closest to its origination. So we deployed a Zero Trust Edge solution. These are all commercial technology that we hardened, scaled, integrated, and deployed into our customer environment. And the goal was same. If you have an on-premise user trying to access a resource anywhere in the cloud, on-premise data center, et cetera, we are completely in real time validating that traffic. Across the board, one of the things we did was we wanted to implement visibility and analytics. And one of our biggest challenge was when we start moving towards the Zero Trust architecture on Thunderdome, we started collecting a lot of logs. And we inherited a DCO environment where we were simply taking all the sensor data, so whether it's network logs, PCAP logs, syslog, and we were simply dumping it into a SIEM. And I'll talk about some of the challenges there. So Thunderdome is live today. It's implemented across DoD. We have other customers that were implementing it as well. It was independently red teamed, and it meets all 152 advanced activities. So we got a lot of kudos from NSA, DoD CIO, and Pentagon leadership on a successful implementation. So traditionally, in a traditional sense, what we saw when we implemented Thunderdome, where we came in and did an assessment, again, the analysts were getting all the logs into their SIEM. And when we start implementing a zero trust architecture, because you're dynamically in real time pulling all this telemetry, you essentially couldn't really implement zero trust because by the time the data gets into your SIEM, it takes too long for an analyst to be able to process or index that data. One of the things we tried to do was rapidly start building out a smart data pipeline. So the idea here is instead of sending everything into your SIEM, we want to deploy a smart data broker. We want to deploy threat intel analytics in line as we are collecting that traffic. We want to do data normalization and data transformation in line. One of our big focus was we did not want to be tied to a specific SIEM. So every customer that we realized has their own favorite SIEM. So we were dealing with customers, for example, we had a customer like Southern Command. They're using QRadar as their SIEM, and they like it. We have customers that are using Azure Sentinel. We have customers that are using Splunk. We have customers that are using Elastic. So one of the things we wanted to do was the ability to be able to provide them the data, if they're a Thunderdome customer, in any format that they desire. So if you're a customer of Elastic, if you're using Elastic, we would translate everything using our smart data broker into Elastic Common Schema, or we would translate it to a common information model if you're a Splunk user. And then we would broker that data to the customer. So we moved from a traditional model from sensor to SIEM to a data brokering model where we would basically have a pipeline where we would do things like raw data ingestion. We would pass it to our data broker, and then we would create smart rules. And using the smart rules, we would determine what type of analytics we want to build. So we have a streaming analytics pipeline. We had an analytics workbench where we're deploying our AI model. Again, the goal here is collect your data from all of the sensors. The sensors could be AWS, GCP, Oracle, on-premise, could be any of the devices on the network. We normalize that data. We are enriching that data in line because we're feeding threat intel data. And then we're basically storing that data in multiple tiers. So we have raw storage, enriched storage, warm storage, et cetera. And we're making that data available to analysts as necessary. The other issue we ran into quickly was we are dealing with a very complex environment where our clients are both multi-cloud and hybrid. So our customer has data sitting in AWS. They have application and workloads sitting in Azure. We are a big user of Microsoft Teams, O365, Microsoft Defender, Intune. So we collect tons of Microsoft data. A lot of that is hosted and packaged up in Azure. We also have a lot of on-premise legacy data. So one of the things we wanted to be careful with is not build a centralized security stack where you're basically moving data around, which is very costly. As you guys all are familiar, when you move data from one cloud to the moment you take data out of a cloud service provider, they charge you an egress cost. So we wanted to avoid that. So the idea was, let's take this architecture that we have built and build a distributed DCO pipeline. So we chose one environment where we have our centralized DCO analysts. It could be anywhere. For our purpose, we used primarily focused on Azure because we had a lot of Microsoft data. And then what we did was we took our data architecture and we basically deployed small instances of this in each of the cloud service provider and on-premise. So if I'm a customer in AWS, I'm collecting logs from CloudFormation, from CloudTrail and CloudWatch. I'm collecting data from Oracle OCI NetFlow collectors. I'm collecting data on-premise. And I'm enriching that data where that data resides. And using things like cross-cluster query, the ability to be able to do distributed query, an analyst is able to go and do threat intel, do threat hunting using this pipeline. So we're not moving all the data from AWS into Azure and vice versa. What we are consolidating are alerts. So we are consolidating alerts from all the different providers. But if an analyst wants to go do threat hunting and wants to take a look at 90-day log or 60-day logs or 180-day logs, they're going into each of the cloud service provider where the data is stored in different tiers. This simplified the architecture. It accelerated threat detection. It significantly reduced our cost of operations. And this is something that's live today, and we're tackling billions of logs that we're collecting from a variety of different sensors. Another benefit, another thing we wanted to do was we had multiple different systems. We had a system that did compliance. We had a system that focused on simply network operations and observability. We had a system that's just doing cyber defense. So analysts ended up with like 3 different dashboards to identify who this individual is, where maybe, for example, somebody executed a rogue PowerShell. Which endpoint, what's the IP address, who's the user, is that device even compliant, is it supposed to be on the network? To collect all that data, what we did was we started consolidating all of that intelligence into a single platform. The reason we could do that is because we moved to this distributed data pipeline. Data is data. Once you start collecting the data, it made it easy for us to be able to make that available as necessary. So if an analyst is looking for compliance, we're enriching that data. So we're basically putting in the name of the individual who owns that endpoint, the IP address that belongs to that particular individual, the activity that individual was performing, the system they were accessing, identity, PKI record, all of those are now in your pipeline. So we're basically, making it easy for our analysts to do threat detection. So this is the architecture we end up coming up with. We have had a lot of success with this. We're deploying it for a lot of different customers. And now what we're doing is we're also pushing this down to the tactical edge. So we have customers that operate in various environments that are very disconnected. And one of the things we are deploying are edge solutions. So, yes, we are a big Cribl fan, and one of the things we're looking at and we've deployed successfully is Cribl Edge, which has been highly successful for us because in a tactical DDoS type situation where we have limited bandwidth, we don't have the luxury of sending all the logs into our central environment. So we use smart detection, we use smart rules to be able to determine intelligently what data to send and what data to keep locally. What are the trends that we're seeing moving forward? Every customer is different. I have this benefit sitting here at Booz where I get to work with commercial users that are a lot more advanced. We work with DoD users and Intel users. So I get to see where the maturity is of different customers. So really the trends depend on, on the customers themselves and how quickly and how good their analysts are to adopt new technology. But obviously, the introduction of artificial intelligence is becoming really real. Not only is AI benefiting, but AI, as I mentioned earlier, is becoming the new attack surface. So a lot of what we are focused right now is, how do we determine like the sprawl of AI models everywhere? How we're protecting when users are interacting with third-party AI solutions like ChatGPT, how are we protecting those APIs? Some of the 3 main things we're focused on right now is AI for compliance. So one of the projects that we're leading, something called Dark Labs Detect, we basically build an agentic AI model that takes artifacts, compliance artifacts like SSP documents, or this application information around what they're authorized for, and builds basically a computer model, a JSON file of that system. And then we are able to then create custom detection logic based on that system. So if this particular application or system is running Java or MySQL, for example, or a specific application, we can create, using this agentic AI model, not only the compliance status of that system, but what are the detection rules that are critical for that system and deploy those. So we think that there is going to be a continued trend towards moving to an AI-based compliance. The second thing is detection and response. So I talked about a lot of this. One of the things I didn't mention is when we created that distributed DCO pipeline, one of the things we also did was we deployed AI models in line. One of the biggest things we were running into was, the DNS logs are very voluminous. You deal with a lot of DNS logs. And DGA type attacks, domain generation algorithms, are one of our biggest threat vector. And it's really difficult to have a traditional analyst go through all the DNS logs and identify threat patterns. So working with a lot of different customers, including CDAO, the Chief Digital Artificial Office, We deployed a DGA model, a DGA algorithm in our streaming analytics pipeline. So when we're collecting DNS log, it would tell us whether a URL, the probability of it being malicious or not. So it made our lives much, very easy because we're using AI model to do threat detection, and then we're also using AI to do threat prevention. Lastly, it's adaptive defense. This is something we're going to continue to see. One of the benefits of using AI models for defense cyber operations is you can have AI models adapt to security threats and take corrective actions. So typically, it would take an analyst to determine patterns in your environment. It would take an analyst to figure out exactly what the type of threats that are evolving, and then for us to be able to build or tune new models to be able to deploy. With AI, you have self-adaptive models, but you have to be very careful how you operationalize them. There's a lot of recommendations. There has to be human in the loop as you get more and more comfortable with your environment. So again, this was a summary of my presentation. I wanted to focus on, number one, making sure people are already aware of what a zero trust architecture is. I talked through a successful implementation called Thunderdome that we did for our DoD client. The challenge we ran into was billions of logs, a distributed architecture with multi-cloud environments. We built a smart DCO pipeline. We had good, solid, successful results. We have it implemented today. We're pushing that down from the enterprise to the tactical edge. Next step for us is to integrate and implement as many AI capabilities as we can to do faster threat detection. I think with that said, that's the end of my presentation. I think you have time for a few questions if you guys have any. And when you say third-party risk, are you specifically talking about third-party vendors that are being integrated into your environment, for example?
Yeah, and I'm thinking about old typhoon.
Sure.
200 critical infrastructure providers had where their networks were attacked because their managed service provider failed to patch their port firewalls.
Yeah. A lot of this comes down to basic cyber hygiene. If you look at the attack that happened in Europe across all the airlines a couple of weeks ago, that was basically an out-of-date, end-of-life Cisco VPN router that was sitting. So that just comes down to people doing their job and making sure that the stuff is tech refreshed. But human is the weakest link. So zero trust it's not the magic bullet. It's not going to solve all your problems. But you're making it difficult for your adversaries. So.
Yeah, thanks so much. So on that note too, traditionally our systems are deterministic.
Yeah.
With AI, they're beginning to become probabilistic.
Yeah.
How do you envision kind of defensive cyber ops or even SOC 3.0 as we integrate agentic workflows within zero trust? I'm sure that's just an extension, right? Can we trust the AI?
I think it's going to take some time. I mean, listen. About 5-6 years ago, there was a buzz around SOAR. Everybody wanted to implement security automation, orchestration, response, and while we have had a lot of success, very rarely have I seen people implement full automated SOAR playbooks. There's always been human in the loop because there's simply that people are uncomfortable implementing, fully automated SOAR playbooks. I see AI being in a similar way. I think there's a lot of concern with things like AI hallucination, for example. I think there's going to be like the actual data that feeds the AI model, AI becoming its own attack surface. So I think there's going to be a lot of governance. There's going to be a lot of training. There is going to be a lot of trial and error. AI will become key component of your AI. Like, we're building AI SOC right now, and we're going to offering that as a managed service. But we have to be very careful how it's implemented, how it's controlled. So AI threat prevention, AI protection itself is going to become this massive field. I think we have time for maybe one or two more, sir. Yeah, so we do both for critical infrastructure and for IT, for OT systems. We follow the Purdue model. For the IT systems, we are basically following what DoD CIO and NSA put out. So they put out zero trust overlays, they put out zero trust activities, they put out zero trust architecture. We're also following the NIST security control model. So all that is baked into our assessment. And then we also build in the MITRE attack framework to look at all the threat vectors. Anyone else? All right, thank you for your time, folks. Appreciate it. Hopefully this was helpful.